This is what a polar equation might look like. The distance from the origin is equal to the cosine of the angle it makes. Now, if you were trying to plot, to draw this graph, if you wanted to do a graph of it, the only real way that you can do it would be to plot lots of points. You might go 0, let's keep it in radians, pi upon 3, 2/3 pi, pi, 4/3 pi, 5/3 pi. Now for each one of those thetas, you could then find out what the R value is. I am making no attempt to say this is right. Can you imagine you calculated R value for each of those thetas? Now, if that wasn't bad enough, and this is why you don't do it, you would get this special paper that's called polar paper. And what it does is it has little, it's a bit like the unit circle with concentric circles drawn around it. And each circle is 1 unit away. So that would be the circle that represents all the points whose R is 1. This would be R equals 2. This is R equals 3. And then what you do is, I'm again making no attempt to draw this thing accurately. Is that you plot those points and then you join them all up and you get that weird blob of redness. Now that is not how we're going to do it for lots of reasons. That could be half an hour of detailed work if you wanted to do a good graph. So how do we get around that problem? Well, let's show you. I should have it set up here. Never find things when I want them. Here we go. I think it's here. Yeah. Okay, are you looking at Canvas, one of the the login page? Is that what you're saying? Right. Do you notice that there's a new couple of guys from last time? There's one called Parametric Equation Grapher, and then underneath it, there's another one called Polar Equation Grapher. Do you see those guys? They're going to make your life dead easy, because almost every question in 8.2 is, here is a polar curve, right? Here's a polar equation. Here's 4 or 6 pictures. Who is he? So when I hit this guy, now who knows with zoom? Are you now looking at a kind of concentric circle with 4 plus 6 cosine t in it, right? The only thing that makes this, and it's tiny, it's really cosmetic, is that they don't call this guy here theta, they call it t. But actually, t is easy to type on your keyboard than trying to find out where the heck theta is. So that's not a bad thing. So let's pretend the question was, what does r equal 4 plus 6 cosine t's look like? Right. So in that little box up there in red, you type in whatever it is you want. This one's already pre-done, but we'll do our own. See this little dial down here? If you the slider, if you slide it over to the end, it'll just make things go quicker. Right. So this one's going 0 to 2 pi, which is pretty typical. And now resume. Now, can you imagine every single one of those little dots you had to find by hand and plot it if you wanted a really accurate picture? Now, you can just let this in do its kind of hypnotic after a while, right? That's your graph. Now, you will have 4 or 6 pictures. One of them, and only one of them, will look like that. And so you will say picture B or picture C or whatever it is, and you're done. You see how easy that section's going to be. You're going to get a graph, you're going to get a picture. And I hope I'm not making this seem a lot simpler than it is. As far as I'm concerned, it is that simple. So I'm going to go up here. Oh, I'm going to pause. I'm going to go up here and I'm going to try a very simple polar equation. R equals 4. So if you plot all the points have the property that the distance R from the origin is 4, can you imagine you're just going to see a circle? Radius 4. Let's find out if we do. Oh, sorry. Got to erase the old one or you have 2 in a row. It's kind of nice because when you watch it, at least you get to see the graph as it's created. Because normally when you do it in a calculator, it's boom, right? You just got the thing and you can't really see where it's coming from. Okay, now let's get crazy. Cosine of t, take away sine of t. So the distance from the origin is whatever the cosine of the angle is, take away the sine of that angle. So imagine projecting at 30 degrees or pi upon 6 or whatever, and finding the sine, take away the cosine, whatever that number is, that's how big you make the r, the distance from the origin. Right, let's erase this fella and try it. Oh, were you expecting it just to be an offset circle? What do you think's going to happen? Oops, I've got to pause this. What do you think's going to happen if I go and I change this guy to 2 and I make this guy 2? Do you think it's going to be the exact same shape or do you think it's going to change in some way? What's your gut feeling?
Change.
Something twice as big as it used to be? Because I doubled everything? Okay, I'm going to keep that one there. That way we can, this time we can compare them. And we'll do a resume. Can I go? Right. No. Could do this all day because to me it's just fun to play about with things. Let's take out trig. And then just do r equals t. Basically, it should say r equals theta, but think of theta, the angle, as being called t here, right? So the distance from the origin is the same as the size of the angle. Any ideas what that shape's going to look like? Anybody? Okay, I've got someone in the chat, so they may be telling me. No, can't really see it in this mode. Okay, here goes. Resume. This is it actually starting from the beginning. That it should join up with the rest of itself. There we go. Basically, you get one of these shapes. They're called helixes. Now, if you try to create a formula that made that same curve happen using x's and y's, you know, the kind of normal Math 141 way of doing curves, right? You'd find it very difficult to get a formula that would make that shape happen. It wouldn't really be a function because for any given x, there's more than one y, but creating it would still be quite weird. And someone did say it. And I don't think we need to worry about watching the launch right now, although it is interesting. Okay, let's pause this. What I'm going to do now is jump to here. Are we watching the WebAssign? Are we on that right page? Good. So let me show you what those questions look like. This should be it. Yeah. We'll just take out those because that's a distraction. So R equals 3 cosine t. It's one of those 6 pictures. R equals 3 is one of these. Actually, we did something like R equals 3, I think, didn't we? R equals 1 or 2 or something. So it's going to be that one there, isn't it? Going to be number 3. So you would just go up here and you say, I'm picking 3, and you'd be right. Okay, it's pretty much the same questions. You know, here's a curve, here's 6 guys, who am I? So 10 minutes, you'll have this entire section finished. That's my prediction. Okay, I'm going to pick something at random. Let's do this one. Do you see the one that says 3 sine 2 theta, right? You can't see that? You can't see any of this, can you? Ah.
Yeah.
Okay, now I'm now going to stop sharing. I'm going to go back in and share. And with a bit of luck, are you looking at it now? Yeah, I can't. Yeah. I don't always know what you're saying. Because I'm seeing it, I think you are, which is not a good assumption. Right, 3 sine 2 theta. There's 4 choices. 3 times the sine of 2 theta. 4 choices. Any guesses? Because really it would be a guesser, because I don't know. Well, I've got a sneaking suspicion that it might be the second one, but I wouldn't guarantee it. Any? Nobody likes guessing? Okay. So, it's one of these 4 shapes. I think I'm going to have to go out and in. 3 sine 2 theta. So, that's me out. Go back in. Where was that piece of software? Here. Here. Are you looking at polar grapher? Can you see that picture? Right. So I can erase this, and it was 3 sine. We'll have to call it 2t, but that's really not a biggie. And erase it. And I guess I'll slide that back to the beginning, and let's go. Oh, it's a 4-leaf clover. Now, I'm not going to do this zoom out and zoom in. That'll take us too long to do that. So, I'm not even sure where it is now. Here it is. It would have been the 3rd one in my list. So there's 1, 2, 3, and 4. The one that looked like the 4-leaf clover was guy number 3. So you've got a whole section with just one task, getting you used to using some software to sketch polar curves of the form R equals. And that's about all there is to that. There isn't really anything else I need to bring up. Are there any questions about that? We feel comfortable with that? My prediction is that that should be an easy section. Does it look like it's going to be an easy one? Just type it in, pick the right picture, move on. Okay, so who is left? Well, the rest of today, we are going to be looking at another type of equation. Not a polar equation, but one that's called a parametric equation. Hold on a second. There we go. So how do parametric equations work? We know Cartesian, right? X's and Y's. When you do Cartesian, you very often get equations that look like that. That's X's and Y's. We've done a little bit of polar. They look like that. Right, if you plot all the points that works. So how does parametric work? Well, parametric equations have the format that you tell the person the x and the y coordinate, but you give both the x and the y coordinate in terms of a variable typically called t. I think they use the letter t because it's very often they use parametric when you're talking about a moving object in space, and t would be time. So an example. Well, how about x equals t squared and y equals 2t take away 1. That would be an example of a parametric equation. And there are two distinct parts to the typical question that you're going to be asked. The first part is the easy bit, which is you're going to be given, just like the polar, here's 4 pictures, which one of them is that guy? Now, if you were going to do it by hand, and I'll just take you through the hand process and then say, look, we do it by software because it's a lot easier. What you do instead is you set up a table with 3 columns. And you start with time is 0, time is 1 second, time is 2 seconds, time is 3 seconds. And if you want to be more accurate, can you imagine 0.1, 0.2, 0.3 at t forever in a day, but you could do it, right? Now, for every value of t, you use this formula here to calculate what the x coordinate would be at that point. So 0 squared is 0, and 2 lots of 0 take away 1 is -1. When t is 1, you plug it in here and you get 1 squared. When t is 1, you plug it in here. When t is 2, you get 4. You plug it in here, you get 3. When t is 3, you get 9. And when you plug it in here, you get 5. And then you plot it on the usual XY grid. So it's very similar to Cartesian, right? X coordinate, Y coordinate. And then you just plot the various points that you've got. So 0, 1, or 0, -1 would be here. Can you imagine 1, 1 would be here? What's the next one? 2, 3, 4. 2, 3 would be about here. And 9, 5, because I didn't do enough space. But could you imagine it was over here somewhere? Now, there are a couple of things that make this a little bit different from just any other kind of curve. In these, there is a direction. You're going in that direction. So you start off at t is 0, and then you go t equals 1, t equals 3. So can you see how parametric is much more useful if you're trying to do an object on 2D space, right? And it's traveling around in this little curve. Not only does it tell you where it is, if you look at the t value that made that happen, you'd even say, it was there at the 5-second mark, but it's now here at the 6-second mark. And you know, at the end of the line, at 20-second mark, it finishes over here. So it's very useful. When you come back to doing Calc 3, hopefully some of you will do Calc 3, we will return to that because it is used a lot when you are modeling moving objects, not just in 2-dimensional space, but you actually can use it for 3- and 4-dimensional space. So have you got the gist of how parametric equations work? You're going to have x equals a function of t, you're going to have y equals a function of t, and what you need to figure out from there is what does its sketch look like. So that's the guy that I am going to do first. I am going to try and show you the software that allows you to sketch a parametric equation. And I believe it's in here. And go back a little bit. No, I'm wrong, it's not here. Is it here? Yes, it's here. Okay. I'll do my usual thing. Are you looking at the home screen, or shall I have to go out and in again? Okay. Do you see I'm pointing at a guy called Parametric Equation Grapher? Do you see that one? So this one below it is for doing all the polar curves, and this one is for doing all the parametric curves. So you click on this guy, with a bit of luck. It'll work. There it is. It took a little bit longer than I was expecting. And this one's designed in its own, format. In this box here, you type in what x is going to be. They're calling it x of t because essentially isn't x a function of t. It's a formula using t. And then they call the y coordinate y of t. And then this guy here, I'm going to say from 0. And this guy here goes to, say, 4. So if you wanted to sketch a parametric curve with those two functions for x and y, starting at time equals 0 and finishing at time equals 4, this is what you should get. And now I should be able to take this fella. It's not, there we go. Now, if I click this box, we get the whole thing, right? Now, do you see that it's not a very interesting curve? It just looks like a bit like, I guess, a quadratic kind of shape. If you take this thing, and what you can do if you move it, can you see how it moves the little dots? And if I check this box, you might see it a little bit better. So like that's 1 second, that's coming up in 2 seconds. Here, there's 3, there's 4, there's 5, and off you go to the end. So there are 2 parts, as I said. The first part is going to be, here is a parametric. The parametric will have an x formula, it will have a y formula, it will have a t0 to 4, 1 to 7, whatever they decide these 2 numbers are. And you will be given 4 or 6 pictures, and your job is pick the one that looks like it. So I'm going to try, because I can, to do t minus 6. Let's be safe here, t space 6. Shouldn't be that hard to do. There we go. And this fella here, hoping it can take square root as an acceptable value. Hey, that's what that one looks like. Now you can even do parametric with trig functions. So the x coordinate is the sine of t, and the y coordinate is the cosine of t. Interesting. Part of a circle. If you kept on going, so if this slider was longer, you'd actually eventually get the whole circle. So why don't I go back here and do 2? Hopefully it'll take pi. There we go. So from 0 to 2 pi, you get a whole circle. So can you imagine the first part of the question is going to be very similar to the polar. You go to this software, you type in the x function, you type in the y function, and you do a t start number, a t finish number, and then you look at the picture and you pick the right one out of the 4 or the 6 choices. So that part will go really fast. So why wasn't there more work to be done? It's because of the second part. This is a bit that's going to slow you down. This is a bit where you're going to have all the hassle, right? So I don't think you're going to have too much hassle with the polar equations and drawing them, or with the parametric equations with drawing them, because I've got pretty nice software that takes the strain off. So now we're going to return. See if there's any questions. Okay, don't think I have any. Okay, here it goes. So what is that last puzzle question? How do you take a parametric equation and turn it into a Cartesian equation? That's going to be the challenge. And let's double check. Are you seeing a big version of this screen? The piece of paper? Right. Okay, so how to convert parametric, basically T's, to Cartesian, which is basically X and Y's, right? Not every function that I'm going to do, or you'll get to do, will be written as y equals x squared, right? That would be nice, but they probably won't. Most of them won't be y equals x squared or y equals x squared plus 22x plus 5. Right? It'd be nice if that happens, and it might happen now and again. What we're talking about here is that you just convert the equation so that you've got x's and y's in the relationship between them. So the kind of solutions that you're going to get are, yeah, you might get that. Be nice if you did. You can also get this. Now, that's not anything you'll have seen in 141, but you know that's acceptable, right? The original thing is now transferred into a relationship between the x and y coordinates. That's all we're going to do. You are likely, probably more likely, to see this guy. Do you recognize that guy? It's a circle, right? But it's a valid one, right? So you could have x's, you could have y's, you could get some kind of mixed up thing with a bit of A and a bit of B and all sorts of stuff. So the whole goal here is just to take your equations, right, your parametric equations, and they call it eliminating the t. That's how it's phrased in the homework. Here is a parametric equation, eliminate the t. In other words, rewrite it in terms of x's and y's. So let's show you some of the major techniques. The first major technique is substitution. That's going to be a big chunk of the questions. You're going to end up using this technique, right, called the substitution method. So let's show you how it works. Suppose that is my parametric equation, right? And I'm going to rewrite that so it looks like one of these guys up here. And the way I'm going to do that is by picking one or other, and it doesn't matter which one I pick, but I need to pick one of these two equations that I can rewrite as t equals without too much trouble. I'm picking this one. Now, how do I get it to become t equals? Well, as long as you do it to both sides, it's OK roll. Do you see what I mean by I can rewrite it as a t equals? Now, if I try to do it over here, can you see how that's a non-starter? So typically, if you're going to use this substitution method, one of the two equations is going to be more likely the candidate for doing this to. Now, where do you think the substitution part is going to come in? Because that's what the method is called.
The y.
Does anybody want to volunteer?
Do you substitute the t that you just got into the y formula?
You know, you are allowed to be wrong. I promise I won't laugh. I know that t is equal to this. How am I going to use that piece of information to go further? You got it.
I don't think you can hear
Thank you,
it.
Andrew. So you replace t with that guy, right? Instead of t squared, you use x minus 1 over 3 squared. Instead of plus t, you now have plus x minus 1 over 3. Okay. Now, I wish I could say we are done, but style points. That is a good question. I cannot hear you because no one's ever said anything. So let me find out. It's me muting myself. That isn't any good. Can somebody just say hello so I can tell if I can hear you?
Hello?
Hello.
Hello.
Howdy.
Ashley, will you say hello?
Hi.
Right, that is it. You are probably answering me and I can't hear your answer. So what the heck is going on? Well, it's one of those days, isn't it? Let's see what we can do here. If you give me a few seconds, I'll see what I can rummage up here. Okay, I did something there. Well, Ashley, will you have another shot at saying hi?
Hi.
No. Weird. Okay, then that explains why I had so much silencing going on, and you were probably trying to tell me. I'm just going to avoid asking questions because by the time I get the mute thing fixed, the lesson will be over. So you're just going to have to bear with me and just listen along because at least you can hear me. That's something. Right. What I was saying is that, look, style points, that is not a nice way to write the answer. We try and make it a little bit better looking, right? So if you FOIL this guy out, you get x squared, take away 2x plus 1 over 9. And this guy, you get x minus 1 over 3. If you turn this into ninths, you get x squared minus 2x plus 1. And you get 3x, take away 3. Everybody is over 9. And now you can put it all together as an x squared plus an x minus a 2 all over 9. So basically, you FOIL things out, you collect like terms, and you try your best at least to make it nice. Are we good? Right. Well, let's. That was an example of substitution. Let's try. Let's try another one. Still on the substitution method. Let's suppose x was equal to sine t plus t squared, and y was t cubed. Now I have to decide to use either the x equals or the y equals, and the one that I'm going to choose is this one, because can you see that this one's relatively easy to turn into a t equals? Typically, if there's more than one t, that's not the one you should be using. So you see how this has got a sine t and it's got a t squared. that's probably not your candidate for the t equals. Now, all I'm going to do now is substitute this t into here. So the x is going to be the sine of the cube root of y plus the cube root of y squared. And there's not too much I need to do to make this look pretty. That's probably as good as it needs to get. So far, so good. Now, this second one is not a substitution method. See, I've got some chat here, so maybe a question someone's asking. No, it must be old chat, okay. Substitution is not going to help us here. If ever you see a sine and a cosine combination like this, you're going to use the method that I'm about to show you. It will also work if you have secant and tangent. If you see x is 4 secant and y is 2 tangent, right? If you see that combination, this is a special situation. You don't use substitution, it won't really get you much. So I'm not going to explain why I'm doing it. I took both equations and I got sine t on its own, and the other one I get cosine t on its own. And then a lot of people make a big mistake here. Can understand it because substitution method is in their head. They take this equation and they say, oh, you know, I could say t equals the inverse sine of x over 4, right? And, you know, do some kind of substitution. Don't. Technically, there's nothing wrong with that, but the answer is so horrible, nobody wants to see it. So we're going to show you a more elegant version of this answer. And don't take this guy and say, okay, well, I'll just do an inverse cosine then. Just as bad. But what I am going to do is I'm going to square both sides. I wish the audio was working for you right now, because I am desperate to see if someone can type in the answer. So you're going to have to do it by texting, or whatever you want to call it, chat. How am I going to get these two guys together? Because there is a way to make it happen. And I got, yes. Can you see that if you just add these two together, it should equal the same thing as adding these two together? So you add them. Now, hopefully this guy here is something you recognize as one of those trig identities that never disappears. And while I'm at it, I'm going to call that x squared over 16 plus y squared over 9 equals 1. So this here would be the Cartesian version of that original parametric. You might know what that guy is. That guy is actually an ellipse. Kind of cool. Right. We've got a few seconds to go. Actually, that went smoother, apart from the fact you can't answer me back. So let's show you what that looks like, if I can find the right page. We'll go more. And here we go, view. Usual question, I guess. Are you now looking, I guess you just need to nod your head again. Are you now looking at the questions on the screen from WebAssign? Right, so what I want to do is just show you what these guys look like. Okay. Right. So in this question here, the one that we're looking at, x equals 2t and y equals 2t squared. Now, can you imagine you plug them in and you'd see a picture, and one of these pictures would be the right one, and you would choose that one. Here is a parametric, 4 guys. Now, do you notice that there's arrows on them? When you're doing the parametric one, do you know that one where you could move the slider so you could see it draw as it went along kind of thing? That would be helpful, because if you look at this line here and you look at this line here, you notice that they're the same line. Well, they shouldn't be, actually. Oh, no, one's above and one's below. I take that back. So I guess in this question, it didn't matter. But I can imagine a situation where both curves are the same curve, but one will have the arrow pointing this way and the other will have the arrow pointing the other way. So when you're creating the shape, have a look at how it's been drawn and imagine there was a little arrow following that pathway, in case it works out that way. Now, if you take this guy, that's what he looks like. Right, that's what the answer looks like in Cartesian format. Let's jump to no, that's substitute. Oh. Question 7, x equals 1 over t and y equals t plus 2. Do you see that that is a substitution method question? Now, I don't know how the textbook is going to work with this. I could use the y equals guy, and that would give me t equals y minus 2, right, and do a substitution that way. I could equally use the x equals guy, and if I did that, t would end up being 1 over x. The problem is that I get 2 different looking answers because of which one I chose to do my substitution on. So I know from experience that this is not great software at predicting more than one way to do the question, right? So it could be you're doing it correctly, but it doesn't match theirs. So if you do it correctly and it doesn't match theirs, you may have to say, okay, I'm not going to do the y equals fella, I'll do the x equals fella instead. That's what I get, and that'll be the right one. Obviously, if you're doing a test, when you show me it working, I will know which one it is, so I'll be able to check it. And I think the rest of the questions are very similar to what is going on here. Okay, well, to finish with, one little pointer that I didn't bring out. Whenever you are doing equations and converting them, it's quite common, in fact, it's almost always going to be the case, that you're given something like this. And it might not even be 0, it could be 1 to 2 and 5 to 6 and whatever else it is, right? So you get a parametric equation, but you only use it from t equals 0 to t equals 5. Or you only use it from t equals 0 to t equals 2, right? Something like that. When you are doing, so I'll do a very quick one to show what I'm getting at. Suppose it was 2t plus 1 and y was t cubed, right? So I'm not going to make my life too awkward. And it was t equals 0 to 2. Now, the first part is pretty standard. Do this as Cartesian, and I'll just get that done right now. I could choose either way, but I'm just going to go this road here. So I'm going to go and say that t is a half x, take away a half. Are you okay with me doing that in my head? So what does that make y? It makes it 1/2 x, take away a half cubed. And by the way, that is actually a good version of the answer, so don't foil that one out, because it looks pretty. But they will have a little thing at the side here, where you're asked to write down where do the x's start and where do they finish. I know where the t's start and finish, and I should be able to use that to figure out where the x's start and finish, right? So how do I do that? Well, t equals 0. That gives you x equals 1. T equals 2. That gives you x equals 5. Do you see how I used the start and finish value for t to find the start and finish values for the x's? So I just forgot that, and I noticed it in one of the questions, that you don't always just get, here's the guy, what's the picture like? That's easy. Convert it to Cartesian, right? We've seen a few of those. They also tag on at the end of some of the questions, and what are the range of x's, right? From this number to that number kind of question. And that is us for today. Oh, okay. We have got a parametric equation. Someone's asked me to explain the last part again. And we're being asked to find the interval of x's, I'll call it that word. Now, I know that x is equal to this, and I also have been told in the question that. So what I'm saying is you pick t equals 0 and you put it here. And that tells me that the x value will start at 1. And then you put that fella in here, and that will tell me that the x value ends up finishing at 5. And so the x's go from 1 to 5. And that's what we write down in our little box in the question. So hopefully that made sense. Right, well, I'm going to have to leave you now because we have another class, and it gives me 5 minutes to find out why everybody has been permanently muted. Hopefully that's just an idiosyncrasy of today. Okay, bye-bye, guys. I guess we'll just have to wave.